Welcome to Curious Minds. Today, we're embarking on a journey that takes us high above the ground, deep into the heart of a thunderstorm, to unravel the wild and fascinating story of hailstones, from their birth in the clouds to their dramatic fall to Earth. Picture this. Above your head, a thundercloud builds. Tall, dark, and dramatic. But this isn't just any cloud. It's a massive engine of weather, a factory in the sky, and what it's making isn't rain or snow, but something much more intense. Hailstones. Hailstones are some of the most powerful and mysterious forms of precipitation. But how does a tiny droplet of water transform into a chunk of ice that can rattle your windows, dent cars, and even devastate crops? To answer that, let's dive into the science of hailstone formation. It all starts with a single droplet of water, suspended high in the atmosphere inside a thunderstorm. Let's head right into the storm and see what's happening overhead. Thunderstorms, especially the towering cumulonimbus clouds, are the perfect breeding ground for hail. Inside these giant cumulonimbus clouds, powerful updrafts, columns of warm, moist air, rush upward at astonishing speeds, sometimes over 100 kilometers per hour. These updrafts are the engines that drive hail formation. As the air rises, it cools rapidly. The humidity inside the cloud condenses into tiny droplets, but here's where it gets interesting. The temperature is often well below freezing, yet the droplets remain liquid. This is called supercooled water, liquid water that's colder than 0 degrees C, just waiting for something to trigger freezing. These supercooled droplets swirl around in the turbulent cloud, clinging to any tiny particle they encounter, dust, ash, or even a microscopic insect. These particles act as nuclei, or seeds, for ice to form. When a supercooled droplet finally touches one of these nuclei, it instantly freezes, forming a tiny ice pellet. This is the birth of a hailstone, a process called nucleation. But the adventure is just beginning. The newborn hailstone is caught in the storm's powerful updrafts, which can lift it high into the cloud, sometimes several kilometers above the ground. As the hailstone is tossed upward, it encounters more supercooled water droplets. Each time it rises, more droplets stick to its surface and freeze, causing the hailstone to grow larger and larger. This process is called accretion. Think of it like rolling a snowball through a blizzard. Each trip through the cloud adds a new layer of ice. Sometimes the hailstone can make several journeys up and down inside the cloud, growing with each pass. If you slice a hailstone in half, you can often see these layers, each one a record of a trip through the storm, a frozen timeline of its wild journey. But what determines how big a hailstone can get? It's a battle between the strength of the updrafts and the pull of gravity. As the hailstone grows, it becomes heavier. Eventually, it reaches a size where even the most powerful updrafts can't keep it suspended. When gravity finally wins, the hailstone begins its rapid descent, crashing through the cloud, through rain, and finally toward the ground. Down it falls, sometimes at speeds over 100 kilometers per hour, smashing onto roofs, fields, cars, or even right into your backyard. The size of a hailstone tells a story. Pea-sized hail means the updrafts were relatively weak, and the hailstone didn't have much time to grow. But when you see golf ball or even baseball-sized hail, you know you're witnessing the result of a powerhouse storm, with updrafts strong enough to keep those icy giants aloft for a long time. The structure of the cumulonimbus cloud is crucial. These clouds have distinct regions: the updraft zone, where hailstones grow, and the downdraft zone, where they fall. Temperature gradients within the cloud, differences in temperature from the base to the top, help determine how much supercooled water is available and how quickly hailstones can grow. The physics of supercooled water is fascinating. Water can remain liquid down to about 40 degrees C if undisturbed, but the moment it touches a solid surface, it freezes instantly. This rapid freezing is what allows hailstones to grow so quickly, layer by layer, as they're tossed around by the storm's updrafts. In some extreme cases, hailstones can reach astonishing sizes. The largest hailstone ever recorded in the United States fell in South Dakota in 2010. It was nearly 20 centimeters across and weighed almost 900 grams. Such massive hailstones can cause incredible damage. shattering windows, denting vehicles, and destroying crops in minutes. After a major hailstorm, scientists and weather enthusiasts often rush out to collect and measure hailstones, studying their layers to learn more about the storm that created them. Each hailstone is like a frozen record of the storm's power and the atmospheric conditions inside the cloud. Hail is nature's way of showing off just how much energy is packed into those swirling thunderclouds. The next time you see a thunderstorm brewing, remember the incredible forces at work high above your head. So next time you hear hail bouncing off your window or see it dancing on the street, remember, each hailstone took a wild, swirling ride high above the earth before coming back down, built layer by layer in the heart of a storm. If you enjoyed this journey into the science of hail, please like and subscribe to Curious Minds for more fascinating explorations of the wonders of our world.